1.6 Piecewise Functions. This is a continuation of our discussions on functions. This is Differential Calculus Fundamentals and Applications. Our playlist is designed for non-math majors. Piecewise function. It is a function whose domain is divided into subintervals, and then the function is defined differently for each subinterval. This is how you write your piecewise function, and sometimes you call this the conditional function. So what we do is we divide our domain into two or more than two subintervals, and then if x is an element of this part of your domain, then we shall define your function accordingly. And then we shall define it differently when x is an element of a different subinterval. Sometimes we call such functions as conditional functions. Why conditional function? Because we define the function according to the conditions that are met. So if x satisfies certain conditions, then this is what we shall do. If x satisfies another set of conditions, then this is what the function will do. We are very much participating into this kind of functions, but we don't call them, or we are not told they are piecewise functions. For example, our grading system is an example of piecewise function. So for example, in a 10-point quiz, our grading system, for example, is something like this. When the score is perfect, 10 points, the teachers would record it in their class record as 100. If the score is 9 points, then it is going to be recorded in the class record as 95. And this goes on up to when x is equal to 0. In other schools, 0 is given a rating of 0, but in other schools, it's given the rating of 60. We also see the piecewise function in the way our tax system is structured. Okay? Let f of x be the amount of taxes paid by a citizen, by an adult, as a function of his or her income. And x is in 100,000 pesos. So if your income is less than or equal to 250,000 pesos, you are exempted from paying the taxes. When your income is between 250K and 500K, then this is what you pay as a tax. It can be 0.25 times the income that you are making, or maybe 0.2 times x. And this goes on. I'm not sure about the exact partitioning of the income, but this goes on, okay? So this is how our tax systems are structured. It is structured very much like a piecewise function. The graphs of piecewise functions appear differently compared with the other functions that we had seen. So sometimes your piecewise function, when you graph it, this is how it might look like, okay? So what we did here is we divided the domain of your function into 3 subintervals, okay? And the subintervals are x is greater than or equal to 0. Okay, so that is from here going to positive infinity. Then another subinterval is from -2 to 0. And then the other interval is from -2 to negative infinity. That is the interval of real numbers that is less than -2. And this is how we define the function. If x is greater than or equal to 0, it is equal to x squared plus 1. Okay? This one. Okay, from here to there. If x is greater than or equal to -2 but less than 0, our function or the value of our y is going to be this. It's equal to 0.5 times x plus 1. And the graph of that in that interval is this one going there. And then when x is less than -2, then our function is defined in this way. Y, or the value of our function, is equal to the square of x plus 2. We shall see a lot of this when we go to limits of functions. Now, how do we write this? Using math notation. So this is how you write it, okay? So f of x, okay, so you will use a brace. It is equal to x squared plus 1, okay? If x is greater than or equal to 0, it is equal to 0.5x plus 1, and it is equal to the square of x plus 2. If x is less than -2. So some books call this the conditional function because you will compute the value of your function depending on the conditions met by the values of x. A real estate agent adopts a new sales commission among his sales agents. If an agent sells a real estate property worth between 0.5 million to 1.5 million pesos, the agent gets a commission of 3%. That is 3% of the sales. If it is greater than 1.5 million but less than 5 million, he gets 5%. But if he succeeds to sell a property worth more than or equal to 5 million, he gets 10%. Construct a function for the sales commission, rates, and sketch the graph. So our domain here is the worth in million pesos of the real estate property. And then we will divide it into 3 sub-intervals. Okay, so these are the sub-intervals from 0.5 million to 1.5 million. Okay, so that is one interval. And then between 1.5 million and 5 million. And then the other sub-interval is when the worth of the real estate property that was sold is more than or equal to 5 million. Okay? This is how we define the function. So let x be the worth of the real estate property. This is in million pesos, and f of x is the commission earned by the sales agent. This is how we construct the function. If the worth of the real estate property that was sold is greater than or equal to 0.5 million but less than or equal to 1.5 million, this is the commission. This is the commission earned by the agent. It's 3% of sales, or 0.03 times x. If the worth of the real estate property that was sold is greater than 1.5 million pesos but less than 5 million pesos, then this is the commission earned by the real estate agent. It's 5% times x. If the worth of the real estate is greater than or equal to 5 million pesos, then this is the amount of commission earned by the sales agent. It's 10%. Okay, so it's 0.10 times x. Now we shall sketch the graph of this function. So if you were to look at this, the function for each sub-interval is defined as a linear function. So we expect to see lines. Okay, for each sub-interval, we shall graph a line. Okay, so here, the horizontal axis is the value of x. It's the sales. It's the amount of the real estate property that is sold in million pesos. And the vertical axis And the vertical axis is the amount of commission earned in pesos by the sales agent. Okay, so from 0.5 to 1.5, this is how we define our function. It's equal to 0.03 times x. Okay, so from here, okay, this is the graph of our function in that subinterval from 0.5 million to 1.5 million. And then from 1.5 million to 5 million, look at this. Okay, that is a closed interval. This is the graph of your function. And then from 5 million for a real estate property worth more than 5 million or equal to 5 million, this is the graph of your function.